Good afternoon, everyone. And first, I'd like to thank the organizer for invitation. And it's my great honor to be here to talk something about neurotriggering of pressure support ventilation. And first of all, why we need a neurotriggering of pressure support. Intrinsic PEEP has been demonstrated in almost all COPD patients with mechanical ventilation, and in more than 1/3 of patients with acute respiratory failure with no COPD. And as we all know, the consequence of intrinsic PEEP include the impaired patient-ventilator interaction and efficiency of ventilatory assist, and increased inspiratory effort and cause dyspnea, and alerts the hemodynamics and even predispose to bell tremor. So during the triggering in pneumatically controlled pressure support ventilation, intrinsic PEEP is a threshold load that we must be overcome to trigger the ventilator. And it has been demonstrated that application of external PEEP can reduce the mechanical inspiratory effort during this condition. Expect the triggering. In COPD patients, increase the airway resistance will prolong the time constant and delay the cycling off of pressure support. And it has been demonstrated that a higher than conventional percentage of peak flow is required to adequately terminate the assist, but not an exact number was suggested. And inappropriate settings for the cycling off criteria are known to worsen dynamic hyperinflation and increase the intrinsic PEEP. So it has been shown in 10 patients with a clinical suspicion of auto-peak. The authors compared NAWA and pressure support at different PEEP levels. And the figures showed that the delay between the onset of EDI and the onset of flow was much lower during NAWA when compared to pressure support. And with the increase of external PEEP, the delay decreased. And also, this paper demonstrated that the pressure required to overcome the auto-PEEP was significantly less during NAWA than with the pressure support ventilation. However, the previous study compared a pressure-targeted mode, pressure support ventilation, to a proportional mode, NAWA. How about the neurotriggering pressure-targeted mode? That means neurotriggering of pressure support ventilation. We take this good idea from Professor Christopher Sindby. This mode means we use the EDI to intonate and terminate the breath, but with a targeted fixed pressure. We use the current commercial mode, NAWA, and we set NAWA level as the maximum level. It's 15 centimeters per microvol. And at the same time, we set the pressure limited to perform the neurotriggering pressure support. The targeted pressure was 5 centimeters lower than the pressure limit. And to compare the neural versus pneumatic control of pressure support in patients with intrinsic PEEP, and to detect the effect of external PEEP, we did a physiological study. And the primary objective is to show that the neurally controlled pressure support can reduce the need for external PEEP to improve patient-ventilator interaction and to reduce both the per-trigger and total inspiratory neural and mechanical efforts in COPD patients with intrinsic PEEP. And the secondary objective is to evaluate the impact of applying of neurally controlled pressure support on breathing pattern and breathing pattern variability. We enrolled 12 adult, intubated, and mechanical ventilated patients with ACOPD. And the inclusion criteria include intrinsic PEEP equal to or more than 5 centimeters of water, and hemodynamic stability. That means the heart rate less than 140 beats per minute and no vessel pressures required, or the butamine less than 5 microgram per kilo per minute, and no sedation or minimum anesthesia with low dose of morphine. That means less than 3 microgram per hour by continuous IV. And the patient can breathing spontaneously, but in need of partial ventilation, ventilatory assist. This is our study protocol. First, for the pneumatically controlled pressure support, we set the flow trigger at 1 liter per minute, and the cycle of is 30% of the peak inspirator flow, and the rate of raise in pressure was 0.05 seconds. And for the neurally controlled pressure support, we use NAVA mode, and we set NAVA level at 15 centimeters per microwall, with upper pressure limits adjusted to achieve the targeted pressure support above external PEEP. It's the same pressure during the pneumatically controlled pressure support. And the EDI trigger was set at 0.5 microwatt, and the cycle off was 70% of peak EDI. And then we compared the pneumatically and neurally controlled pressure support at different levels of external PEEP. External PEEP was set at 0, 40%, 80%, and 120% of the static intrinsic PEEP. And then we measure the patient ventilator interaction. Here we see the patient characters, and we enrolled 12 patients with pneumonia and ECOPD. And the statistic intrinsic PEEP, which measured during volume control ventilation, was 5.8. It's from 5 to 8 centimeters of water. And this is the breathing pattern. We can see that the mean airway pressure and the external PEEP were matched for the pneumatically and neurally controlled pressure support at the same targeted levels. And compared to pneumatically controlled pressure support, we see the tidal volume was lower and the neurally breathing frequency was higher during neurally controlled pressure support until the external PEEP was set at 80% of intrinsic PEEP. And with the increase of external PEEP, we can see that the neurally breathing frequency decreased during the neurally controlled pressure support, but not during the pneumatically controlled pressure support. With respect to the patient-ventilator interaction, we can see here, this is the pneumatically controlled pressure support with 0 PEEP, and the middle was is a pneumatically controlled pressure support with external PEEP set at 80% of intrinsic PEEP, and the lower one was a neurally controlled pressure support with 0 PEEP. And we can see that the orange shaded bars indicate the EDI without assist that with efforts, and we can see the neurally controlled pressure support at 0 PEEP synchronize the assist and eliminate the with efforts, and patient ventilator interaction was worse in pneumatically controlled pressure support than the neural controlled pressure support. If we see the topographic distribution of timing annals for triggering, that shows on y-axis, and cycling off showed on x-axis. We can see that during the neurally controlled pressure support, even at a PEEP of 0, the triggering was concentrated within ranging from the -5 to 25% for the triggering annul, and -5 to 5 annul during cycling off regardless of external PEEP. And during the pneumatically controlled pressure support, we can see a wide spread variability ranging about the -10 to 60% for triggering error, and about -30 to 30% of cycling off regardless of the external PEEP. If we use the neurocycle index as a parameter to evaluate the patient-ventilator interaction, we can see that the neurocycle index was constantly lower during the neurocontrolled pressure support. And with the increase of the external PEEP, we can see the neurocycle index decreased during the pneumatically controlled pressure support, but has no effect during the neurally controlled pressure support. And this picture shows the neural and mechanical efforts. We can see here, triggering effort was constantly and markedly reduced during the neurally controlled pressure support compared to the pneumatically. And the increasing of intrinsic PEEP reduced trigger effort during the pneumatically controlled pressure support. At external PEEP was set at 80% of intrinsic PEEP, but did not change during the neuro-controlled pressure support. And the total mechanical effort decreased with the increasing of external PEEP during both pneumatically and neurally controlled pressure support. And we also measured the mechanical efforts between the pneumatically controlled pressure at 0 PEEP and neuro-controlled pressure at 0 PEEP. And we measured the change between the pneumatically controlled pressure support at 0 PEEP and at PEEP-E cited as 80% of intrinsic PEEP. We see a pretty good correlation here. That means the total inspiratory mechanical effort during neuro-controlled pressure support at 0 PEEP matched the pneumatically controlled pressure support at external PEEP set at 80% of intrinsic PEEP, and suggested that neurotriggering is at least as effective as titration of external PEEP to overcome the intrinsic PEEP and reduce total inspiratory mechanical effort. So our result demonstrates that neurally controlled pressure support ventilation is feasible in patients with COPD demonstrating with intrinsic PEEP. And the neurally controlled pressure support compared to conventional pneumatically controlled pressure support improve patient-ventilator interaction and reduce the inspiratory effort even in absence of external PEEP. And the third, neurally controlled pressure support overcomes the need for external PEEP in order to overcome the intrinsic PEEP in COPD patients. So in the future, neurally triggering of pressure support might be the next conventional ventilation mode to deal with intrinsic PEEP. Thank you.